Good morning, students. In the last class, we have seen the types of electrolytes, types of materials, and the redox titration. And today in this session, I am going to explain electrode potential and its types, electromotive force, and electrochemical series. So let us see the first topic, that is electrode potential and its types. But before going to see the electrode potential and its types, you know what is mean by the electrode. Here electrode is nothing but it is a metallic wire or metallic rod which is able to pass the electricity. That is mean by the electrode. But when electrode is releasing the potential. So now let us see the electrode potential. The tendency of a metal to get oxidized or reduced when it is placed in a solution of its own salt solution is called electrode potential. Here own salt solution is nothing but, for example, let us take the zinc electrode. So when zinc electrode is dipping in its own salt solution, own salt is nothing but that salt solution is must be containing the zinc ions. That is mean by the own salt solution. So when zinc is dipping in the zinc sulfate, copper is dipping in the copper sulfate. So like that, when we are dipping the electrode in its own salt solution, it is releasing the potential difference. That potential difference is called electrode potential. So the tendency of a metal to get oxidized or reduced when it is placed in a solution of its own salt solution is called electrode potential. So what happens here? When the metal is dipping in its own salt solution, either the metal undergo oxidation or metal is undergo reduction. So due to undergo oxidation or reduction, it is releasing the potential. That potential value is called electrode potential. So when a metal is placed in a solution containing its own salt solution, so we are taking the example of metal M, its own salt ions. That means that solution must be having M plus N ions. Then the metal may undergo either oxidation or reduction. If the metal undergo oxidation, then the positive metal ions may pass into the solution. That means here let us see metal undergo oxidation. But before that, you know what is mean by the oxidation here. So when metal undergo oxidation, metal loses electrons. Metal losing n number of electrons to produce Mn plus. So if metal losing one electron, we will get M plus plus electron. If a metal losing 2 electrons, M2 plus 2 electrons. Metal losing 3 electrons, M3 plus 3 electrons. And if metal losing n number of electrons, we will get Mn plus. So that we are explaining here, if the metal undergo oxidation, the positive metal ions may pass into the solution. So these are the positive metal ions. These metal ions are releasing in the solution. So that is oxidation here. If the metal undergoes reduction, then the negative ions may get deposited over the metal. So the negative ions may get deposited over the metal when the metal undergo reduction here. So this is the reverse reaction of the oxidation. When metal ion is gaining the number of electrons, when it is gaining the electrons, it gets negative charge. So the negative ions are releasing, these negative ions are deposited on the metal. So that is reduction. So when metal is dipping in its own salt solution, metal either undergo oxidation or undergo reduction. Due to undergo oxidation or reduction, metal releasing the potential value, that potential value is called electrode potential. So simply I am giving the definition of electrode potential. The potential difference between metal and its salt solution is called electrode potential. So the symbol of electrode potential is capital E. So now I am giving the example of electrode potential. Now we said that either metal undergo oxidation or metal undergo reduction here. So now I am taking the two examples. In one example, metal undergo oxidation. In another example, metal undergo reduction here. So the first example, zinc in ZnSO4. Metal, its own salt solution. So zinc is a metal, its salt solution is zinc sulfate. See here, the solution is containing zinc ions. So that's the reason it is called as its own salt solution. So when zinc is dipping in ZnSO4, let us see what happens. When zinc is placed in a solution of its own salt solution, zinc undergo oxidation with the release of electrons. So we know what is mean by oxidation, loss of electrons. So when zinc is dipping in ZnSO4, what happens? Zinc metal is undergo oxidation and it is losing 2 electrons. When it is losing 2 electrons, it is giving Zn plus 2 and releasing the 2 electrons in the electrolyte. The electrons liberated in the process accumulate over the surface of the metal. So this is the surface of the metal, this is the zinc metal. Whatever the electrons are releasing, those electrons are deposited on the surface of the metal. So due to releasing the electrons on the surface of the metal, a layer is forming on the metal, that is the oxide layer, and this is also called as the double layer here. So due to releasing the electrons, it is forming a double layer on the metal. So in ZnSO4 solution, zinc is undergo oxidation and releasing the potential value. That potential value is called oxidation potential. So next example, copper in copper sulfate. Copper in copper sulfate. So here copper is dipping in the copper sulfate solution. Copper is dipping in the copper sulfate solution. So when copper is placed in the solution of copper sulfate, the copper ions in the solution gets deposited over the metal and hence the metal becomes positively charged. So whatever the copper plus 2 ions present in the electrolyte, these copper plus 2 ions are deposited on the surface of the metal. So when the metal is deposited by the copper plus 2, the metal gets the positive charge. Now this metal is undergo reduction. That means whatever the metal is coating here, that means copper plus 2 is coated over the copper here. That copper plus 2 is gaining the electron, that means 2 electrons to get neutral atom. So due to gaining the 2 electrons, again it is forming a layer, that is a double layer, and releasing the potential. So that potential is called the reduction potential here. So when zinc is dipping in the zinc sulfate, it is releasing the oxidation potential, that means zinc is undergo oxidation. But when copper is dipping in the copper sulfate solution, copper is undergo reduction. So simply in electrode potential, either the metal undergo oxidation or metal undergo reduction. So when the metal undergo oxidation, metal gets the negative charge, and when the metal undergo reduction, the metal gets positively charged. Yes, so that is oxidation and reduction of the metal in the electrode potential. So now let us see the further topic of electrode potential. Types of electrode potential. But before that, now we have seen that maybe the metal undergo oxidation or metal undergo reduction here. Yes. So based on that, electrode potential is two types. One is oxidation potential and the reduction potential. In oxidation potential, the metal is having the tendency or ability to undergo oxidation. But in reduction potential, the metal is having the tendency to gain the electrons. So let us see the definition of oxidation potential and the reduction potential. In oxidation potential, The tendency of a metal to get oxidized when it is placed in a solution of own salt solution is called the oxidation potential. So in oxidation potential, metal is having the tendency or ability to lose the electrons. Now the next one, reduction potential. The tendency of a metal to get reduced when it is placed in a solution of its own salt is called reduction potential. So in oxidation potential, metal undergo oxidation. In reduction potential, metal is undergo reduction. Yes. So I will take the example of oxidation potential and reduction potential by using galvanic cell. So everyone, you know the galvanic cell. In galvanic cell, the left part we are having the zinc and zinc sulfate, and in the right part we are having copper and copper sulfate. But we know that zinc is undergo oxidation and copper is undergo reduction here. Yes. So zinc is having the oxidation potential value, copper is having the reduction potential value. That example only I have given here. That is Zn in ZnSO4 and copper in copper SO4. These two are combining here. ZnSO4 and copper SO4. These two are combining. And when these two are combining, the zinc is acting as anode and copper is acting as the cathode. I will explain you at the end of this section why the zinc is acting as anode and copper is acting as a cathode when these two are combining. But just remember here, zinc is undergo oxidation, copper is undergo reduction. So zinc is having oxidation potential value and copper is having the reduction potential value. So that is oxidation potential and reduction potential. But we are not considering oxidation potential. We are considering the reduction potential values only for every electrode. So let us see what is the reason behind that. So each half cell is associated with a potential difference whose magnitude it depends on the nature of the particular electrode reaction and on the concentration of the dissolved species. Yes. So here half cell is nothing but the cell is having two electrodes. One electrode is dipping in its own salt solution and other electrode also dipping in its own salt solution. That means in cell we are having two potentials are releasing there. The first potential is called oxidation half cell and the second potential is called reduction half cell. That is meant by the half cell here. In cell, half of the part is called half cell and the remaining half part also called as the half cell. That is oxidation half cell and the reduction half cell. But here each half cell is associated with a potential difference whose magnitude depends on the nature of the particular electrode and the electrolyte. It is depending on the electrode and also depending on the electrolyte. Based on that only, electrode is undergo oxidation or undergo reduction. And the sign of this potential difference depends on the direction in which the electrode reaction proceeds. So either the electrode reaction proceeds in the forward direction or in the backward direction. Either it is undergo oxidation reaction or it is undergo reduction reaction. So based on that, the potential value will be positive or the negative. Yes, but if you have either positive or negative, you will be get confused. So because of that reason, we are considering only reduction part instead of the oxidation. So we are considering reduction for both potential. Even it is undergo oxidation, we are considering reduction only, but we are giving the sign opposite. Yes, if the metal is undergo oxidation, but we are considering reduction over there. So due to considering reduction, what we are giving, if the value is positive, whatever the value we are considering, that will be the negative. But if the value is negative, whatever the value we are going to consider, that will be positive value. So because of that reason, what we are doing, we are considering only the reduction potential values. Reduction potential value as it is, but oxidation potential value will be opposite for the given reduction potential value. So we are considering only reduction potential value, we are not considering oxidation potential value. And also from IUPAC system, we have to consider only the reduction potential values. We should not consider the oxidation potential values. So wherever the values are there, those values are reduction potential values, those are not oxidation potential values. So let us take one example. So this is the example here, Zn slash Zn plus 2. Here Zn slash Zn plus 2 is nothing but Zn is giving Zn plus 2 by losing 2 electrons. So what is this? Is it the oxidation reaction or the reduction reaction? It is the oxidation reaction. Zn is giving rise to Zn plus 2 electrons is the oxidation. But as per the IUPAC system, and to avoid the disturbance and to avoid the confusion, what we are doing, we are considering only the reduction. We are not considering oxidation. So what we are doing, we are writing Zn plus 2 slash Zn. That means Zn plus 2 is giving Zn. That means Zn plus 2 is giving Zn by gaining the 2 electrons. So actually Zn value for Zn plus 2 value is 0.76. But what we are doing, we are taking this value as minus 0.76. So in the cell Zn plus 2, double vertical line, copper plus 2, copper. So I will explain you later in electrochemical cell how to write the cell notation. Maybe already you have seen in the intermediate level. But again I will explain you the trick how to write the galvanic cell notation. But just see the example of galvanic cell notation. Zn slash Zn plus 2, double vertical line, copper plus 2 slash copper. The zinc appears on the left side, that means to the double vertical line, this is at the left side, and copper plus 2 copper is at the right side. The left side undergo oxidation, not reduction. But here we are mentioning reduction reaction instead of oxidation to avoid the confusion. But whatever the value is there for this, what we are doing, we are writing the opposite sign to this electrode potential value. We are considering the opposite sign electrode potential value for this, because we are considering only the reduction potential values as per the IUPAC system. So now let us see the further topic in electrode potential, that is single electrode potential, standard electrode potential. But before that, you know what is mean by electrode potential here. Electrode potential is nothing but it is the potential difference between electrode and its salt solution. Yes. So the same definition for single electrode potential also. In the single electrode potential, it is a measure of tendency of a metallic electrode to lose or gain the electrons when it is in contact with a solution of its own salt solution. So it is a measure of tendency of a metallic electrode to lose or gaining of electrons of the electrode is called the electrode potential. So the same definition for electrode potential and the single electrode potential. The symbol of electrode potential is capital E. So now let us see the next one, that is standard electrode potential. So what is the difference between single electrode potential and the standard electrode potential? Single electrode potential is nothing but here either the metal undergo oxidation or metal undergo reduction when the metal is dipping in its salt solution. But whereas in standard electrode potential, the electrode is maintaining at the proper conditions. That means here the metal is maintaining at room temperature and also the concentration of the solution is known here. So that is the standard electrode potential. That means electrode potential value at the standard conditions. What are the standard conditions here? The standard conditions are the known concentration of the given electrolyte and the room temperature. Yes, it is a measure of tendency of a metallic electrode to loss or gain of electrode when it is contact with a solution of its own salt of 1 molar concentration at 25 degrees centigrade. So simply remember the electrode potential value at room temperature and 1 atmosphere of electrolyte is called standard electrode potential. Yes. So this is electrode potential and the standard electrode potential.